Hello, this is Mohammad Riad Arifin. I'm making this video with my teammates Mushfiqur Rahman and Sridhar. So, in this video, I'll describe the codes used in assignment 1 to explore clustering on the retail data sets to figure out patterns in customer purchase and products demand to help businesses take better decisions. If you look at the codes here, which we used Colab to run, you'll see first we placed our data provided to us, sales 219 in the drive, and then connected to it. After that, we also needed to connect to MySQL server, created a DB for it, and then imported the data. We were successfully able to import more than 3 million rows for our experiment. After that, we used Python to connect to that DB and extract all the features. As an example, you will see the first 5 rows of that data here. Now I will pass to my teammate, Mushfiqur, to carry on.
So for we are using the k-means clustering. So here, um, k-mean algorithm cannot work directly with raw retail data because it has millions of rows with a single transaction. So we use SQL queries to group and aggregate the features, and you can see in this SQL, we counted the number of visit of the customer and the total item by the customer and the distinct product, counted the distinct product and count the total spending, the revenue. So uh, here we can see some of the data that I read all this thing into the pandas. This I load the data in the pandas with panda read SQL and read the data. So here I can see that this is my customer numbers and this one is the features which we selected with the customer primary key and all four of the features. So now I just describe that data. So I have the statistical overview. So here you can see that the, uh, the, the standard deviation means and other maximum values. So it clearly state that there is some there's lots of outlier because in the revenue section I found some negative value and the maximum is more it's very high. So we need to scale the data as well. And I also check the missing values, like is there any missing values in my features. So there's no missing value. I just check that, and then we need to remove the outliers anomalies. So these four are my features for the customer side, and here we compute with the percentile trimming 1 to 99%, and here we can show that low and high level, which has the lower point and which is the high point, and find out the extreme outlier. So before and after, we counted that before removal the outlier, that this is the customer numbers, and after removing this is the customer. So we remove the that extreme customers extreme number from our data. And now we can also see that the means and the standard deviations go lower, and the maximum goes to only 60. This is the data right now, the structure of data. And for the k-means, we need to compute the the k value. So how would we compute? So for that, we use that. Before that, we need the standard scaler. So here we use the function called standard scaler, and it scale the data which is fit into the which calculate a jet value, and it fits into the into the distributions. So here we recalculated all the statistical values like mean, standard deviation in the same scale, and then we compute the value of k. So we use two methods, which one is elbow method and another one is Salhouti score. So here we can see for elbow method, the point should be in 3 or 4, and for Salhouti, the score is bigger, is good. So the thing is that Saloti score we have for 2 is 7, but for 3 is 0.69, and for 2 is 0.77. So we took, based on those two, we took the best one, which is, I think, for 3. So that's why the 3 K equal to 3 has the strong Salhoti, also 0.69. So it's much sensible. That's why we took k equal to 3. And for clustering, right now, our next group member will describe all the things.
Now I will present the final clustering results for both customer and the products. I will explain what each cluster represents and then validate the separation visually using PCA. Now, whatever the value we got from the elbow method, that k equals to 3, we are training the final result set like cluster using k equals to 3 and assigning each customer a cluster label. Here we can see the head method prints the like what are the first 5 rows of the cluster. Here we can see the cluster column from here, like it is added to this data set. And moving on to understanding clusters using mean and the sizes. To interpret the clusters, I computed the mean of each feature per the cluster. From the summary, the results, the cluster means increases logically from cluster 2 to cluster 0, where cluster 2 has the majority means low value customers. Cluster 0 has like medium value, the fewer customers, and the cluster 1 has the smallest means high value customers. In this pattern, exactly what we expect in the real retail data, many occasional shoppers and few high spenders. And moving on to the PCA visualization. Next, I use the PCA to reduce the customer features from 4 dimensions to the 2 dimensions. Only for visualization, PCA preserves maximum variance. So it's standard method to make clusters visually interpretable. The explained variance ratio shows that most information is captured in the first 2 components, and the scattered plot displays each customer as a point colored by the cluster, helps us visualizing verify the separations. Here we can see clearly all the 3 separations. And finally, I mapped the customer IDs to the meaningful business names, like low value customer equals to cluster 0, high value customer equals to cluster 1. Similarly, 2 for the low value customers. And similar to the customer segmentation, I applied the same pipeline to the products as well, like feature aggregation, outlier removal, scaling, and choosing k equals to 3 by performing elbow method and the Silhouette score. After that, we train the final k-means clustering to obtain the 3 interpretable product segments. And we have performed the PCA on the products too. Here we can see the PCA visualizations too. Overall, the clusters are logically ordered, business interpretable, and PCA visualizations support that segment structure is meaningful. Thank you.